Chocolate, while a delicious treat, can be completely ruined if stored improperly. Most places recommend that it's stored between 65 and 70 degrees Fahrenheit and away from direct sunlight and moisture. Some, therefore, have come to the conclusion that they should store it in a refrigerator. But that is also suboptimal, as there is a risk of condensation forming on the chocolate, which can totally ruin the texture. But then if you leave it outside, it may melt. However, assuming that the chocolate was undamaged by the storage method, does the temperature of the chocolate affect its taste? That is the question we are asking today. Thus, we have the study, chocolate, cold or warm? Cue the intro. Oh wait, there is no intro. Whatever. Right to the data collection it is then. Now armed with the question, we can begin the collection of data and make a plan at the same time. First, we took 2 large bars of Trader Joe's milk chocolate and turned that into 60 smaller bars of Trader Joe's milk chocolate. 30 of each were randomly assigned to be kept in sealed containers in a refrigerator and in a room at room temperature. Now we have 2 containers, one of cold and one of warmish chocolate. At lunch, we invited students onto campus to test both chocolates in a single blind experiment. The containers were identical, and ideally the chocolates were identical as well. Before handing out the chocolates, however, we used a random number generator to determine which chocolate sample we would give out first, removing potential confounding variables and other potential sources of error. Each person tries both chocolates and then was asked which one they preferred. Their answers were then recorded into a document. A lunch later, we had something that looked like this. Very nice graphs, to say so myself. Right, now that we've met all the conditions, we can start doing the actual calculations. First, we're going to be finding a z statistic, which is the statistic minus the parameter over the standard deviation of the statistic. The first thing we're going to need is the proportion of individuals who chose the colder chocolate over the room temperature chocolate. This would be P is equal to the success, or the number of students who chose colder chocolate over room temperature chocolate, over the total number of students, which is going to be equal to 36 over 61, which is 0.590164. The second thing that we need is the standard deviation of the statistic. This is equal to the square root of the hypothesized proportion times 1 minus the hypothesized proportion divided by the sample size. Plugging in our hypothesized proportion of 0.5, we get the square root of 0.5 times 0.5 over 61, which will get us 0.064018. Now, armed with the proportion and the standard deviation of the statistic, we can plug it into our formula, and we get 0.59 minus 0.5 over 0.064, and then I will snap my fingers, and we get an answer for our z statistic, which is 1.408406. With the z statistic, we can now take a two-sided test, where our p-value is equal to 2 times the probability that z is greater than 1.408406, which is going to be equal to 0.159. What can we conclude from this? Now, here's a fancy conclude statement. Here's a not so fancy conclude statement, basically saying the same thing. There is no evidence against students just randomly selecting which chocolate they like best, with no influence from the temperature. If you're wondering why, it's because the p-value of 0.159 is greater than the alpha significance value of 0.5, so we failed to reject the null hypothesis. And that's how we can make this conclusion. Now, the question is, who can this conclusion apply to? Generally, we would like it to apply to generally all high school students, as I would expect that Canyon Crest is close enough to other high schools. But, if anyone's watching this video from out of state, why don't you try this experiment at your school and see what your results are? Of course, there is a flaw in having everyone around the nation repeat the same experiment over 100 times. But that's a question for a different topic, or a different video. Why don't you guys discuss as to why in the comment section below? In the end, even though we didn't reject the null hypothesis, and there was some difficulty in actually executing the experiment, such as transporting buckets of chocolate, we still learned valuable lessons about the storage of chocolate. If anything, this brings up more questions, such as, if we had more temperatures to test from? Or which additives are the best for chocolate? There's a world of questions we can ask about chocolate. Thank you for listening.